For you, I'll be talking about computer organization and architecture, and this is the scheme of the subject, and these are the details of the subject, or I can say modules. And there are total 6 modules in this particular subject. And of course, I will be teaching all these modules in a sequential manner. But if you see my plan on the right hand side, you will find that there is a slight change I have done, and that is the plan I will be following. Like chapter 1 we will be starting today, chapter 2 we will be doing, and then we will do chapter number 4, that is data representation and different algorithms. Then chapter 5. Then chapter 3 and chapter 6. So if you see this entire book, you will find that what modules are given in the syllabus. I'm not going to follow it blindly for teaching learning process, and I'm going to teach you the way you will best understand. So on the right hand side, you will find that this is our flow. Slight changes there if you see, but otherwise it is okay. In the initial days, this particular plan is in the same format like a syllabus. Of course, you will be appearing for 18 marks of examination. The pattern of examination is not defined, and it will be decided later. There will be two IA1, IA2 divided by 2, that is 20 marks, and there is a term work of 25 marks, and total weightage is 125. I will be contributing to these 125 marks. That is a simple summary. There is no practical examination or there is no oral examination in this particular subject, but it is a foundation subject, I can say, especially for computer engineering and information technology. Total credits that you will get is 3 plus 1, 3 for theory concept and 1 for laboratory, or I can say practical, and total is 3 plus 1. I think you must have started with your regular sessions at your institutes, so let's go ahead and see how we are going to go. These are some do and don'ts when we go for session number 1. This is my practice that I will share this PPT, and this PPT I'm not going to talk about, but you are just going to read, and I will be waiting for a few seconds. Okay, so I think all the points have been communicated. What is the best way to perform online teaching learning process? Let's go ahead. Let's talk general planning of the subject for a couple of minutes. I recommend that you carry one notebook with you during our regular sessions on Saturday, mainly for writing concepts in COA. Now your syllabus is huge. Let's be very practical about it, because even a microprocessor like 8086 is partially included in this particular subject. So what we will do, we will be mainly focusing on understanding the concept, and whatever is most important for exam or for your further semester studies, that I will be giving. I will dictate those points at few places. Okay, not at every place, because it is not practical, but definitely you will get the material for your studies. One way is all these lecture PPTs which I will be using, that I will be converting in PDF, and I will be sharing with you on weekly basis. You'll be getting all soft copy of the material for COA in the proper question answer format, which is already been under progress. Module 1 is ready and other modules are in progress. So all that you'll be getting, and plus whatever is most important for examination, like I said, that all I'll be giving. But that is something which is very important. Otherwise, we will not be writing much. We will be understanding more, and our focus is on conceptual discussion. One point I want to add is at any point, if you feel certain PPT is important or you want to refer, you can take a pick of that for your quick reference. Otherwise, anyway, PDF I will be sharing, like I said. I will recommend one standard textbook for this subject, that is Computer Organization and Architecture by William Stallings. Very nice textbook, I will say, and this is dedicated for computer organization. And if possible, you can refer ebook because it's easily available on internet. If you search, you will definitely get it. And prerequisite for this particular subject is a digital logic design, which is included in this particular subject. That is a very surprising part, because if you see module 1, you will find that there are some basic concepts of digital logic design, and on the top of that, this subject has been developed or designed. So this is general planning about the subject. I hope everybody has understood, and there are no major queries about this planning, and everybody will agree that this is the best planning we can do. Now let's go into this subject, because almost everything important is complete. Since it is day number 1, it is necessary that all this should be communicated at once. Okay, now let's see what is the agenda for today. Now today we are going to start with number systems. We will understand what are different types of number systems. We will try to do convergence between those number systems. We will understand what is the methodology or algorithm for conversion. And And if time permits, we will introduce some basic digital hardware, or I can say digital system introduction. But that depends on our other 3 agenda points, because that is on top priority for session number 1. Now before I start, I just want to have a feedback on chat box, and that feedback is: are you ready to go ahead, or you have any query about whatever I said for last 10 minutes? If you have any query, you can ask. If you do not have any query, please type words YES. I call these words as magic words, because these words will indicate to me that all is well and you are ready to go. Yeah, that's great. So I'm expecting some more words. Okay, that's fantastic. Okay, very nice. And last but important, before I go ahead, at any point if you get a query, either you can type in chat box, or you can unmute and you can ask. Normally, after every 30 minutes or maybe 25 minutes, I ask students if they have any query, they can get it clarified. Okay, so this session will be interactive and I will be in communication with you. But in between also, if you have any specific query, you can unmute and you can ask. I think you can unmute if I'm not mistaken. And if you can't unmute, then the only option is the chat box. Okay. Anyway, so let's start. Now I'm coming out of chat box, all is well, and everybody is on screen. Let's move. Okay, there is a reply, and I think what I said is right. Okay, let's go ahead. The question is that what is the number system and why this discussion is important. Basically, number system is used to represent numeric data, because if you see the statistics and if you Google it, you will find that lots of information is in the form of numbers. Question is that how you are going to represent those numbers. Just for your information, whenever you work on a computer and when you type some characters like your name or ABCD, technically what goes in computer is a number. Computer is a machine, and computer don't know alphabets, or computer don't know special characters. It's a human who knows these are the alphabets, these are the special characters. But for computer, everything is a number. That standard is called as ASCII, ASCII. I think you must have heard about it during your programming related subject. So my point is that everything in computer is actually a number. Even when you take a password, which is a very critical information, actually it is a number. And the question is that how this number is represented inside a computer. For that, we use number system. That is the significance. So in your syllabus, this has been put on the great thought. We must know about number system, its reason, why we use it, and what are the different possibilities. So question is how we represent integer data, and that particular answer is a number system, especially decimal number system. Because we humans, we always talk digits from 0 to 9, and all combination of 0 to 9 is called as a decimal number, or the base is 10. That is a very interesting theory, and question is why we use decimal number system, why we use number system with base 10. What is the reason? And one of the thought process which is really interesting is that human has 10 fingers, and because human has 10 fingers, the natural capacity for human to count is 10. That means 10 symbols, basically 0 to 9. And because of that, decimal number system is so popular in humans, and it is traditionally being used. I'm sure that this particular reason will be a new reason for you, how decimal number system is so important and how it is linked to the human. So the point is, we use decimal number system whose base is 10, and we are expert in that because in school days we used to add, subtract, multiply, and so many things we used to do. But other than decimal number system, we also have some other number systems. No doubt, for human it's decimal, and I said the reason, 10 fingers. But the question is that how our data is represented in the computer. If I go listeners, I said computer is a machine, and how this data we present inside the machine? That's a good question. Answer is, we always represent this data in computer using zeros and ones called bits. I think by common sense, everybody knows that bit stands for binary digit. So this BI actually stands for binary, and this P is the last letter of this word digit. So BIT, that is how this called as bit. 0 and 1, that is called as bit, and 12 is bits. And naturally, when I say that any data we represent using zeros and ones or bits, there are only two symbols. One symbol is 0 and other symbol is 1, and such number system is called as binary number system. So now you can see what is the difference between human and machine. Human talks decimal number system, and machine talks binary number system. So there's a gap. Binary means 2, and there are two symbols, 0 and 1. Base is 2, basically. Question is that if I talk decimal numbers and if my computer talks binary numbers, I talk base 10, computer talks base 2. How we are going to bridge the gap? Because it's like I'm talking in English and my computer is talking in French. And though they are talking meaningful, but communication will be very difficult because computer might not know English and I don't know French. Then how this communication can be established? For that, we must know how we should be able to convert from one number system to other number system. We must know the algorithm for that. So if I want to go into the domain of computer, zeros and ones, what is the algorithm? If computer wants to come in my domain, that is decimal, what is the algorithm? Then that communication will be possible. For that, we need to understand what are the different ways we can convert one number like decimal into binary or binary into decimal. That is a very clean thought process. But don't be under the impression that there are only two number systems. No, these are two giants, I will say. The giant called human who talks decimal and a giant called computer who talks binary. But other than these two giants, there are some small players which are also visible. Let's see what are those players, and we'll put it in a table format. These are the common players when we talk about number systems. I already said one is decimal, and this particular number system is used by humans. Okay, and base is 10, and we have total 10 symbols, 0 to 9, what we talk. And we don't use it in computer. Second is called as binary. Base is 2, we use two symbols, 0 and 1, it's called bit, B-I-T. Human don't use it, computer use it. Okay, if you have good listeners, one question will come in your mind, why computer use 0 and 1? Why not there are 3 symbols? Why not there are 4 symbols?
Because
why not there are 5 symbols? Yeah, go ahead, that's great, if you're answering, I'm happy, tell me.
in computers we use they work with small so like electrical signals where 0 is off and 1 is on, so there are only two possible ways, that is on or off. So in this way the message is transmitted by tasks are carried out, so that's why
excellent, that's right. So for others, what our friend is telling is acceptable, and that is what we are going to learn in our module number 1, that is digital systems or digital hardware. It works with only 2 levels or voltage. Okay, I will not go into that because it will be too early and we will follow our agenda, but we will study because it is coming in our plan. So my point is that why computer use binary? The answer is that binary is actually the voltage level of digital signal. And we'll see that. Okay? I don't want to make your life complex in the beginning. Let's do it step by step. Third important number system is called as octal, if you observe. And base is 8. Now this is totally outdated. Let us be very practical, okay? Because when I'll be teaching this subject, I'll be telling you lots of practical applications and I will be mapping it also. So I will not say because in the syllabus it is very important. No. Octal is a number system which is totally outdated. Nowadays, nobody uses octal number system. The only reason why this number system we are referring is because older computers were using this particular number system. And in those computers, total 8 symbols were used, that is 0 to 7, and they have a support for octal number system. But you can see in the table that neither is used by humans nor is used in a computer. That is the reason I said it is totally outdated. Okay, so when you say which number system is commonly used in decimal, binary, they are at the top, and hexadecimal is at level number 3. Anyway, let's talk about hexadecimal because it is the next layer in our sequence. Fourth number system, which is commonly referred, is called as hexadecimal, and base is 16. Okay, now this is slightly weird type of number system, but it is extremely useful. Why is weird? It is there are 16 symbols if you follow my table, such that all the symbols from 0 to 9 are used, and symbols from 10 to 15, because if we apply the common sense, then here we say base is 16, that means symbols will be 0 to 15. Like here we are saying base is 10, symbols are 0 to 9. Okay, so here we will say my symbols are 0 to 15. What we do, we represent symbol 0 to 9 very similar to decimal. See, okay, so if somebody asks you, because I always say that smart people ask smart questions. So if somebody asks you value 9 in decimal and value 9 in hexadecimal, is there any difference? The answer is no. What ask him? Value 9 in decimal and value 9 in hexadecimal, is there any difference? Answer is no, because they use the same symbols. Observe it. But afterwards there's a huge difference, because 10 is represented by A, 11 is represented by B, 12 is represented by C, 13 is represented by E, okay? No, D, 14 is represented by E, and 15 is represented by F. So 10 to 15 is represented by alphabets, A to F. Okay, alphabets are numbers. That's why I said it's a weird number system, because who will say alphabets are numbers? Only engineers will say that alphabets are numbers in hexadecimal system, obviously. So we say that A is not alphabet in hexadecimal, it's a value, it's a number. B is not alphabet, it's a value. C is not alphabet, it's a value. D, E, F, they are not alphabet, it's a value. Okay, so always remember when you refer any hexadecimal number, ABC, okay, do not say alphabet ABC, it is value ABC. Because I started with this question, don't forget. how we represent integer data. So what we're talking is numbers. Okay, fine. Let's go and conclude this discussion because now we discussed for about 20 minutes and we have gathered some common number systems in our discussion. Question is that where we use hexadecimal number system, because that particular answer we need to give what is the application of hexadecimal number system. Hexadecimal number system we normally use in applications. Hexadecimal number system we normally use in applications called embedded system. Please turn on the light. Hexadecimal number system we always use in applications called embedded systems. Okay, you may not be knowing, but just because we're talking, I thought we should give one example. Anyway, now let's see some more details about this number system. If you have any query, you are free to ask. Check it out. I'm in chat box. Any query, guys? Up to this. We just introduced number system. We talked about the significance and what are the numbers. Check it out. If you don't have a query, don't forget my magic word. Yeah. What is that? Embedded system is an application which is based on microcontroller. Remote control, traffic light, scrolling display, washing machine. These are all embedded systems. Please mute. Those who don't have a question, please mute. Okay, thank you. Let's go ahead. Now let's see how to move between these number systems. Okay, something very interesting to start now. Okay, let's try to understand how we move between these number systems. These are my 4 number systems. Okay, and I already said what is their significance, what are their symbols, why we talk number system. Okay, and now one important understanding, or I will say skill, SKILL, is how to move between these number systems. If I'm a human, let's assume that I'm here, and I want to know what is there inside the computer, or how my data will look into the computer. I must know how to move this way. Observe it. Okay, so I must know how to move from decimal to binary. Then I will know, okay, I'm talking 10 value, okay, or 15 value. But in computer, it is something different in 01010. Or if I'm a machine and if I talk 101010, I must know how that value will look in terms of human. That means decimal. So all these particular conversions we should be able to do. And let's see what are the possibilities. You can see decimal to binary, binary to decimal, decimal to binary, binary to decimal. We should be able to do. Decimal to octal, octal to decimal. We should be able to do. Decimal to hexadecimal, hexadecimal to decimal. We should be able to do. Binary to octal, octal to binary. We should be able to do. Binary to hexadecimal, hexadecimal to binary, we should be able to do. And the last one is octal to hexadecimal, hexadecimal to octal. These are all possibilities. And that is what we are going to focus today. Mainly we are going to focus, I will say. But we are fortunate, I will tell you why. Because otherwise, if you do some simple calculation, you will find that total conversions are 2 plus 2 plus 2 plus 2, that is 4. Okay, 4 into 2 is equal to 8. 8 plus 2 is equal to 10. And 10 plus 2 is equal to 12. There are total 12 conversions between these number systems, which are very important. Okay. But these conversions are simple. Once you understand 2 conversions, let me go there. Rest all the conversions, they follow the similar track. So we can reuse the algorithm. Please understand the word reuse. Okay, we don't have to develop the algorithm every now and then. We can reuse the algorithm with a very small modification. So we only have to understand how to convert decimal to binary and how to convert binary to decimal. Our 50% work is done. Because once that algorithm is clear, you have to just apply that algorithm in slightly different way. And we'll get most of the other conversions. So let's see how we do primary convergence. Primary means human to machine, machine to human. Okay, let's see how we do it. Here we go. Just a little reminder, no doubt I will be sharing all this in the form of PDF, but it will take a couple of days or a little more. So whatever you feel important, you please note it down. Note it down means you can take a pic for your immediate reference. Otherwise, I will share. Okay, and take your notebooks ready because in that notebook we are going to put one example and you will be solving it as a small practice. Okay, let's start. Question is how we convert human data into the machine data. Decimal means human, binary means machine. For that, there is a very simple algorithm. You are from IT, so you are well aware how we write algorithm. Stepwise solution is called as algorithm. What is algorithm? We will go through it quickly and we will convert our algorithm into practical example. What we do? We take a number, okay, and we divide by 2. Why we divide by 2? Because my target number system is binary. Target means where I want to convert. Okay, so we divide by 2, and we identify, we mention or note remainder and quotient. Because after division we get 2 results. One is remainder and second one is quotient. And what we do? We repeat this particular process, division process, by taking quotient as a dividend. So your numerator, next numerator will get quotient because dividend means numerator. So next numerator is your quotient, divide by 2, get remainder, you will get new quotient, which is your numerator, again divide by 2. So this becomes a looping process. The question is where to stop. For that, what we do, we repeat this particular process till my dividend is less than divisor. So इसका मतलब है numerator should be less than denominator. तब तक ये process हम लोग रन करेंगे. Okay, let's convert into example so that we get clarity. See, algorithm is important because बिना algorithm लिखे you cannot start solving the numerical. आपके पास algorithm होना जरूरी है because I already said you are from IT and you are aware that before we write a program we always follow certain standard method like we write algorithm, we have a problem definition, for that we write algorithm, we make a flowchart and then we go for the program. That is how we normally solve the problem. So you must know the algorithm and we just quickly discuss about the algorithm. Now let's see how we do it. Now there is a question in front and that question is convert 125 decimal in binary. Okay, convert 125 D. Can you see this D? This D is a term that represents decimal, मतलब basis 10, and you have to convert it in binary. So what we do? We follow this algorithm. I already said. Let's apply. 125 is my decimal number. Start division by 2. Now if you divide 125 by 2, you get quotient as 62 and you get remainder as 1. Because 62 into 2 is 124 and 125 minus 124 is 1. Okay. Divide 62 by 2. Observe it. If you divide 62 by 2, you get quotient and remainder. So if you divide 62 by 2, then my quotient is 31 and my remainder is 0. Okay. You must have noted how I am writing. I am writing quotient and remainder in the same row. Observe it carefully. Okay. Some people write remainder at the top, somewhere here, and quotient at the down. Okay. That practice is also okay because you should not get confused. That is the reason I am sharing other method also how it is written. But if you want to avoid confusion, then I suggest that you write quotient and remainder on the same line. Observe it. So it becomes very easy. Let's continue. We divide 62 by 2 and quotient is 31, you can see, and remainder is 0. Okay, let's continue. Divide 31 by 2, my quotient is 15 and my remainder is 1. Continue. Divide 15 by 2, my quotient is 7, my remainder is 1. Continue. Divide 7 by 2, my quotient is 3, my remainder is 1. Continue. Divide 3 by 2, my quotient is 1, my remainder is 1. Okay, now be very alert because this particular method you will be able to do just by solving single problem. Now see what is going to happen. If I try to divide 1 divided by 2, okay, if I try to divide 1 divided by 2, is it okay? Recollect your C programming. I'm assuming that your C programming concepts are crystal clear. Okay, my word is crystal clear. So if you divide 1 divided by 2, that is what I'm trying to do here. 1 divided by 2. Actually, your answer is 0.5. You got me? Actually, your answer is 0.5. But you must have studied one rule in programming, and that rule is int divided by int, result is int. I repeat, int divided by int, result is int. Okay, that means division is not possible. Because if we apply here, then int divided by int, result is int. So this particular fraction part will go away, and only integer part will be taken, and this is the integer part that we have taken. Okay, that means quotient is 0, and when quotient is 0, that means division is not possible, and because division is not possible, whatever is the number, that becomes the remainder. Observe it. This number becomes the remainder, it becomes as it is, because division is not possible. So we take that number as it is. Okay, and if you have good listeners, very clearly I said that when you collect all the remainders, because all remainders represent your binary, this all is your binary, because it's a string or group of zeros and ones, this you have to collect from bottom to top. Observe it. So 125 is my decimal number, and by collecting all remainders, I am collecting from bottom up approach. See, this way I am collecting all the remainders. See, 1, 1, 1, 1, 1, 1, okay, 1, 1, 1, 1, 0, 1, 0, 1 in binary. So this is normally called as yes, what is called as superscript or subscript. Do you remember Microsoft Word? Okay. So this is the way we normally present our answer. Now such questions you can get in your final examination. The reason is traditional examination also questions are asked on the conversion. Somewhere 5 to 10 marks of questions are always asked on the conversion. Different conversions. This is one we have started. And even in multiple choice you may get such questions where we do some effort and you will identify correct answer like 125 decimal. You will get 4 options, and this can be a correct option that way. Let me once again review this algorithm and then we'll go ahead. Okay, we'll go for opposite conversion and I will give time to raise your queries. Okay. I said how to convert human data into machine data because 125 is for human and how it looks into the machine. That's the question. For that, one algorithm we discuss. Start with the value 125 divided by 2. Go on writing all quotients and go on writing all remainders. Preferably quotient and remainder you write on the same line. Okay. To avoid confusion, of course. Continue. At the end, you will find my numerator is less than denominator. Okay, 1 by 2. And if you remember basic rule of programming, int divided by int, result is int. So 0.5 because 1 by 2 is actually 0.5. You only take 0 and you ignore 0.5. So what you get is 0. That means division is not possible. And because division is not possible, your number that means numerator or I can say dividend becomes remainder and we collect it from bottom to top and we get the final answer. Okay. Now let's continue with one more possibility. This is the final answer. Second possibility is if my data is in machine format 0101, how I will get it in decimal format. Okay. Now this is very simple because the algorithm that we are going to use is a complementary algorithm. Okay. If you divide 4 by 2, you get quotient as 2. To get 4, you will multiply 2 into 2, but you get is 4. So if you divide, you compensate it by multiplication. It's so simple. If you divide, you compensate for multiplication to get original data. So here, if you recollect the previous one, we have applied division for converting decimal to binary. Complement to division is a multiplication. So conversion of binary to decimal we do through multiplication. This is the algorithm. Observe it. Just have a look. What we do, we start with the process and we multiply every bit by 2 raised to n. What is n? N is the weight of the bit. What is that? I'll show you with example because in algorithm probably it may not be very clear. Okay. Don't worry. In 5 minutes you will understand what is the weight. But you cannot skip algorithm. You cannot say that I'm able to convert a binary to decimal directly. No, you must know algorithm because why you do because there's an algorithm. Okay. So multiply by 2 raised to n. That is the point. And go on doing this multiplication, which is basically the add and multiply type of operation. Okay. Multiply, add, and repeat the process for all the bits. Let me clarify what is the weight before I go for actual example. Let's talk decimal number system. Suppose my number is 125 because in the previous example I have taken this number as one example. Okay. You will remember just like all these concepts we have referred in school. Okay. It's so important. Our school is so important. This is for units place. This is for tens place, and this is for hundreds place. Okay. You will say why sir is telling us? We already know. But that is related to the weight. Okay. What word is visible in the algorithm? This is for units place. This is for tens place, and this is for hundreds place. If I ask you a question, can you tell me why this is for units place? Why is for the hundreds place? Why is for the tens place? Can you tell me what is the reason? Yeah. Anybody?
Because after that, if you put all zeros, it becomes that many. Like after 1, you put 2 zeros, it becomes 100. So 100 zeros.
Okay. So good attempt. Anybody else?
Powers of 10.
Very nice. And can you slightly elaborate? Okay.
Like the unit digit is 10 raised to 0, then 10 is...
Very nice. Very nice. Good. Very nice. Anyway, now let's make this point clear to everybody. This is my decimal number, and I was talking about weight. Okay. My question was, why is this called as units place? Why is this called as tens place? And why is this called as hundreds place? The answer is, this particular position is called as 0th position. Is it okay? This position is called as position 1, and this position is called as position 2, and these numbers are called as weight. Observe it. Okay. And in any number system, these numbers are common. You talk decimal, you talk binary, you talk octal, you talk hexadecimal. Because these 4 we are talking. Reasons are known to you. In all 4 number systems, you count 0, 1, 2. Okay, for weight. Again, I'm saying for weight. And now you will be specific because this particular number is in decimal number system. Okay, we are taking example 125 decimal. And because this particular number is in decimal, this particular position is 10 raised to power 0. Now what is 10 raised to power 0? No, mathematics is scale even for me when I did my engineering. But 10 raised to power is very simple. That is 10 raised to power 0 is 1. Anything raised to power 0 is 1. That's a simple rule in mathematics. Okay, so such simple rules comes, I like mathematics. But when that triple integration and all that comes, then I get scared of mathematics because today also I don't know why we do triple integration because I'm doing application based course. Anyway, forget it, coming back. Point is, 10 raised to power 0 is 1, and that's why it's called units place. 10 raised to power 0 is 1, that's why it's called units place. 10 raised to power 1 is 10, that's why this is called tens place. And 10 raised to power 2 is 100, that's why this is called hundreds place. And that is what is the weight. Is it okay? Now let's go for the actual example because now we have a clear understanding what is weight and how we are going to use. Here is a simple example. Question is convert 101011 binary in decimal. Okay, B for binary. या B लिखेंगे या फिर ऐसे 2 लिखेंगे. Okay, दोनों तरफ से आपको आइडेंटिफाई होना चाहिए कि ये बाइनरी नंबर है. Okay, B लिखते हैं. इसीलिए दोनों तरफ from both angles I'm showing you. Okay. Point is, I want to convert this number in decimal, and already we are clear that my algorithm is a multiplication algorithm because I divide to convert decimal to binary. I will multiply to convert binary to decimal. It's complicated. Let's see how. This is the method. Okay, this is the best approach you can use. And if you follow this approach, I don't think any time you will go wrong. Normally people what they do, they solve horizontally. जैसे horizontally solve करते हैं ये. लेकिन इसमें क्या होता है कि आपको ऐड करना होता है. अगर ज़्यादा बहुत ज़्यादा बिट्स रहेंगे तो आपके नंबर्स भी उतने ज़्यादा रहेंगे. फिर अलग से आपको ये करना पड़ता है. तो ये ऑर्गेनाइजेशन बेस्ट ऑर्गेनाइजेशन है. Let's see. What we do, we list this particular binary in column format. See, 1 1 0 1 0 1. इस पे आपने केयरफुली नोट किया होगा ये डिक्वेशन नहीं है, उसका मीनिंग है. ओके, बिट 0 इसका मतलब है इसका वेट 0 है, ऑब्जर्व इट. ओके, वैल्यू उसका 1 है, लेकिन ये जो है वो वेट के लिए है. ओके, एंड दैट बिट आई हैव टेकन फर्स्ट, ऑब्जर्व इट. Okay, now be very alert because I'm going to use 2 new words and that I will require in coming session when I will talk digital electronics. This particular bit, which has minimum weight, मैंने आपको बताया what is the weight. I hope you are sticking to the screen and you are doing single tasking. Single tasking is teaching learning. Humans can only do single tasking. Machine can do multitasking. So forget WhatsApp when we are discussing. Okay. Point is, this particular bit whose weight is 0 is called LSB. LSB का मतलब है least significant bit. Okay, least significant bit. Least significant क्या है? उसका weight है. Okay, smart question are smart. Okay, smart people ask smart question. Person ने ask you उसको LSB क्यों बोलते हैं? Okay, and then silence is the best medicine. Okay, this should be answered. उसका LSB इसलिए बोलते हैं उसका weight है वो minimum है. That's why it's called as least significant bit. That is called as LSB. And the bit which is at the highest weight, this particular bit, it is called MSB. MSB stands for most significant bit. ये दो terms को आपको याद रखना है because when we will be talking about some further concepts, I will require these two terms, LSB and MSB. Okay, and I will ask you a question. Okay, so what I'm doing in this particular conversion, if you have a look, I'm writing all the bits from LSB to MSB, LSB to MSB. मैं लिख रहा हूँ column format. Okay, LSB आगे का weight और ये MSB. So this is my MSB just for your better understand. And this is my LSB. Okay, and now I will multiply because I think 3 times I said the algorithm is complement. Division becomes multiplication. You multiply by power of 2. Okay, 2 is to n. Where n is the weight. Now what is the weight of this particular bit? 0. So you will multiply 2 is to 0. What is the weight of this particular bit? 1. So you will multiply 2 is to 1. What is the weight of this particular bit? 2. So you will multiply 2 is to 2. What is the weight of this particular bit? 3. So 2 is to 3. What is the weight of this bit? 4. So 2 is to 4. What is the weight of this bit? 5. So 2 is to 5. Just 10 minutes before I said weights we always count 0, 1, 2 in all number systems. Okay, for our convenience. And that is how I have counted. The number binary है, counting around 0, 1, 2, 3, 4 like that. And now it's a very simple mathematics. Just a school going to do it. It's so simple. The mathematics part. Anything raised to power 0 is 1, so 1 into 1 is 1, 2 into 1 is 2. Ignore this term because it is multiplied by 0 and you generate all the product. And finally you add all the product. What result we get is value in decimal. So what you get is 43 in decimal. Now if you have any queries, you are free to ask. We have discussed for exactly 1 hour. Check it out if any queries are there. Yes guys, any queries? You can ask. You're most welcome. If you don't have any queries, then you have to write in chat box. You know what to write. Yes, that's great. Fantastic. Piyush, I already said that I may not be dictating all these particular details. The reason is that I have a definite time limit to complete your syllabus. Okay, so I said I'll be sharing all the material in a soft copy format. It may not be handwritten, but all my PPTs I will convert in PDF and I will share. And I will share ebook. No, all this will not be copy paste in ebook. Ebook will have all the basic concepts. Examples will be there. But what animation I'm showing you, the way I'm explaining, all that may not be in ebook because all that we have lectures, you know. Because what human can do, nothing, nobody else can do. It's so simple. But all notes will be there. All examples and all that will be there. Yes, Abhijit sir, you can please come in because I told you that you can come at 6 after 6 o'clock. Yes, Abhijit sir,
Thank you, sir.
Yeah, you're most welcome.
Yeah. Yeah, so students, this is Abhijit and I work as a program manager for PG Division and Vidyananda. So basically, we teach students GATE and GRE. So I guess all of you are from second year, right? Second year of engineering. And this is the right time to plan for your career. Like, of course, you all have two options. You can go for jobs or you can go for higher studies. So for both options, you have to work really hard. So I was in the lecture since last 10 minutes and I was quite motivating you all of you. So sir, I बोल रहे कि a machine can do multiple tasks, but human brain can do one task at a time. So now this is the time for you to plan your career. Second year of engineering, right? Because by the time you complete third year, it will be too late, right? So now it's time to take information. You attend various sessions. You decide what exam to prepare or for what jobs you are going to prepare based on your your quality and your caliber and everything. So I have two announcements to make. One is tomorrow we have a webinar which will be specifically MTech in IIT plus public sector undertaking recruitment process. So what are the prerequisites? Okay, of course, GATE is the exam that you should appear to get into IIT for master's program or public sector undertaking. And the good news is we have a guest lecture. We have a guest lecture from one of our alumni. His name is Bhavendra Jha, currently working in Indian Oil as senior officer. He's working in Indian Oil. He has he has secured all the ranking of 116 in GATE and like he was selected in IIT Madras and many PSs, but he finally joined Indian Oil. And he will be taking tomorrow's session at 11 a.m. I will be sharing the registration link in the chat box. So please do attend the session. It's totally your cost. You just need to spend your time. So there is it. So please attend that session tomorrow morning 11 a.m. Apart from that, if you have any questions or any doubts or if you want a one-on-one counseling from Vidyananda expert on GATE or GRE, I'll share a one-on-one counseling session link. Okay, so you please click the link and book a one-on-one counseling session if you want our expert to get to you and do attend the webinar. Okay, because it's number one, it will be taken by someone who is just 3 to 4 years senior to you and he has achieved a lot. Okay, and he was a student from St. John Palgar. He was a very average student and then he cracked GATE. He went to IIT Madras. Now he's in IIT. So he has a very tough and very long journey. So उनसे अगर आप सुनोगे तो आपको एक motivation definitely मिलेगा and you'll get to learn a lot of things how he had prepared, what kind of challenges he had got and everything. So that is it. In just a couple of minutes I'll share the link and details in the chat box. Please do click the link and book the session for yourself. So that is it, sir. Thanks a lot for giving me the time and students all the best and now continue with your lecture. Thank you, sir.
Yes, you're most welcome. Let's continue. So if you don't have any queries, then let's move on. But please again acknowledge me. You please type yes so that I will come to know you are ready because in between there is a change of topic. So I'm waiting for your response, guys. Yeah, that's great. Fantastic. Okay. Fantastic. Anyway, now let's go ahead. Okay. We have done two important conversions. One is decimal to binary and second one is binary to decimal. And now let's go ahead with some other conversions on the similar lines. Now our base is defined. Now it will not be so difficult because we are aware what is the thought process. These are the homework questions for you. I request you that you please take a pic of this because next session when we will meet, I will ask you whether you have completed the homework or not. So whatever notebooks you are using in that to solve all these particular questions. Okay, so please take a pic and solve it once our session is completed. I'm waiting for a few seconds so that you will take a peek and you will get these practice questions. Convert decimal to binary, there are 5, and convert binary to decimal, there are 5. 5 numericals. Okay, I hope you must have taken the peek and you will try to solve it. Okay, and now I'm going ahead. Now let's see how we convert decimal number to octal number. Now our journey is very simple because we have to just apply the same algorithm with one digit we have to change. And you must have identified what is that digit. Let's see. This is the algorithm to convert decimal number to octal number. Okay, and if you compare algorithm to convert decimal to binary, you will find that it's copy paste, our favorite operation. That operation is called copy paste. And there is only one change, and that change is instead of dividing by 2, we are dividing by 8. Observe it. Why? Because my target number system is octal, and base of this number system is 8. Rest all the points are same. I have not changed any letter, any word. I have only changed one digit. Instead of dividing by 2, we will be dividing by 8. That is the only difference. What you see. Let's see how we do it. Of course, through example, and you must have noted that all remainders again we pick up from bottom to top, very similar to decimal to binary. Here is the conversion. Now this look is different, and I always say looks matter, and this look is different look. Okay. Let's assume I want to convert 125 decimal to octal. Okay, so what I will do, I will write 125 and I will start dividing by 8. If I divide 125 by 8, my quotient is 1 5 because 15 8s are 120. Okay, and the remainder is 5. And as usual, I'm writing my remainder and quotient in the same line. Observe it. Okay, so this is my quotient and this is my remainder, just rough words. Same like decimal to binary. That's why I was saying in the beginning that if we understand two conversions, then our main understanding will be done. I'll continue. I will divide 15 by 8. 8 ones are 8. My remainder is 7. Okay, and now division is not possible because if I write here 8 again, then 1 divided by 8, this particular division is not possible. I talked about it if you recollect. And result is 0 point something. We only take integer, which is 0. Observe it. And because division is not possible, my numerator becomes remainder. See, very similar to binary. And we collect all the digits from bottom to top as usual. So I collect 1, I collect 7, and I collect 5. This is 175 octal. So 125 decimal is equivalent to 175 octal. And our conversion is complete. And you must have noted that we are using same algorithm like decimal to binary, division by 8 instead of division by 2. Question is, how we convert octal to decimal? Again, what algorithm we have applied for binary to decimal? Same algorithm is there. You can see. With only one difference. And that difference is we are multiplying every bit by power of 8 rather than power of 2. This is the only difference. Rest, all the words, all the letters are copy paste. And you are already aware what is the meaning of weight, how we count the weight, how we use it in the conversion, all that we have seen in binary to decimal conversion. Let's see how we do it. I want to convert 124 octal, either O, this is not 0, this is O for octal, or you can represent it as 8, okay, base, into decimal. This is the question. Again, I will go in the same way. You will see my approach is absolutely uniform. I am not changing my algorithm, I am not changing my approach. There is zero confusion, it's crystal clear. So what I am doing, again, I am collecting all the digits. Now I will use the word digit because we are talking octal. In binary, I use the word bit. I am collecting all digits from LSB to MSB, okay, 2 more terms. This is my position 0, this is my position 1, this is my position 2. These are all my weights, okay, this is 2. Oops, I'm sorry. Okay, or I will erase it better so there is no confusion. It doesn't take much time. And I will write it properly. Okay. Whatever we are doing, it should be neat and clean, though it is slightly rough. Okay, so these are the weights. And this particular digit is now called as least significant, okay, digit, LSD. हम लोग उसको now LSD बोलेंगे. बाकी नंबर सिस्टम में हम लोग बोलेंगे least significant digit because its weight is 0. And this particular digit is called MSD. MSD का मतलब है most significant digit. Okay, MSD and LSD. And again, we find I'm writing the LSD, then I'm writing the next digit, and then I'm writing MSD in a column format. And I'm multiplying by 8. This is weight is 0, so 8 raised to power 0. This weight is 1, so 8 raised to power 1. This weight is 2, so 8 raised to power 2. And straight kids mathematics we are doing. Anything raised to power 0 is 1, so this is 4, this is 1 6, this is 448, and just we add, we get value in decimal. So we converted octal number into decimal number. And 2 more conversions we have completed. Check if you have any queries, if any question you want to ask. Again, I'm in the chat box. Check it out. Any query? I'm waiting for your reply. Okay, that's great. Okay, very nice. I want more people to respond. That's great. There are other 30 guys because I can see only a few common messages. Engineering is a teamwork. Engineering is not a single individual's work. Okay, anyway, you need to participate and you need to be little responsive. That is what is the request and suggestion. Anyway, now let's go one step. I'm coming out of chat box and now again on full screen. This is next homework that you will be doing for converting decimal number to octal number and octal number to decimal number. I again suggest you that you take a peek of this so that you can complete this homework maybe in 1 week before we meet again next Saturday. So take a peek. I will wait for a few seconds. This is homework number 2. Homework number 2. Convert decimal to octal. There are 5 numericals and convert octal to decimal. There are another 5 numericals. Okay, now let's go ahead and again concentrate. We have worked for about 1 hour and 20 minutes. Let's go ahead. Now let's convert decimal to hexadecimal. Okay. Let's see how we convert decimal number into hexadecimal number. I will say this discussion we are doing the third time. Okay, why? Because we use same algorithm called division. So अभी समझना ये है कि if you are a human and if you want to go to a number system like binary, octal or hexadecimal, you do division. Okay, the only difference is what value you will use for that division. If it is binary, you will divide by 2. If it is octal, you will divide by 8. If it is hexadecimal, you will divide by 16. Otherwise, algorithm is basically a division. Okay, but this particular conversion is slightly tricky. The reason is that when I started, I clearly said that hexadecimal is slightly weird number system, and we use alphabets A to F, which represent value 10 to value 15, so that we have to apply in this particular conversion. And that's why this particular conversion we have to do pretty carefully. Though the method is same, but there are some letters, alphabets visible, which are actually values. So we have to be careful. Let's see how we do it. Let's convert 1, 2, 3, 4 into hexadecimal. Okay, so 1, 2, 3, 4 is my decimal number, and I want to convert into hexadecimal. And my approach is a simple division approach. We divide 1, 2, 3, 4 by 16. Okay, so if we divide 123 by 16, then 16 5s are 18, 16 6s are 96, 16 7s are 112. Okay, so 7 is the quotient, and 112. If we subtract from 123, then we get 11. Okay, if we take 4, then it becomes 114. So again, 16 7s are 112. 114 minus 112, the remainder is 2. Okay, again I'm writing remainder and quotient on the same line. If you see carefully. Now be very alert. My numerator is greater than denominator, so my division continues. 77 I will divide by 16. 16 4s are 64 and 16 5s are 80. So forget about 5. 16 4s are 64. So my quotient is 4. Now, if I subtract 64 from 77, I get result as 13. If I subtract 64 from 77, then my difference is 13, and 13 in hexadecimal number system is B. Because already in the beginning I said A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, F represents 15. So my remainder is 13. So that 13 I will represent by hexadecimal value D. Observe it. This is the trick, or I can say catch, we need to take care. Now further division is not possible because if I try to divide, my denominator is larger 16 and my numerator is 4. So my quotient will be 0 and my remainder is the value itself. And as usual, I will pick digits from bottom to top because that's the algorithm. And my result is 4D2 is the value in hexadecimal. So 1, 2, 3, 4 decimal is equivalent to 4D2 in hexadecimal. Okay, I think same algorithm we have applied third time to convert decimal to hexadecimal. Now all three possibilities we have taken up, that is decimal going to binary, decimal going to octal, decimal going to hexadecimal. Now let's complete reverse process also. So one group will be completed, one common group will be completed, and that conversion is hexadecimal to decimal. If you see the algorithm, again you will find it's some multiplication algorithm. Octal, hexadecimal to decimal, you have to multiply. Okay, so if I go to that diagram, this is all the journey that we have done in almost 1 hour and 30 minutes. It's a good journey, I will say. Okay, and this is where everything that slowly started. Then what I can say, if I want to use this diagram as a reference, then if you want to go from decimal to binary, hexadecimal and octal, we divide. And if you want to come from binary to decimal, hexadecimal to decimal, and octal to decimal, we multiply. It's so simple. And that is what we are currently doing for the last major conversion. Okay, then some other permutation combinations will follow. Okay, this we have discussed. Let's go ahead. I was talking that it's a multiplication algorithm with only one change, and that change is we are going to multiply with the power of 1/6. Okay, it's not the power of 2, not the power of 8, already done. It's the power of 1/6. And again, something called as weight, if you see. Let's do it, and we will understand by doing. I want to convert ABC hexadecimal, H stands for hexadecimal, or you can write like 1/6 is the base, into decimal. Okay, you will find again same uniform method. Only value are changing, algorithm is same. This is my weight 0, this is my weight 1, and this is my weight 2. Okay, and like I said, this particular digit has smallest weight, which is called least significant digit. Again, LSD. हम लोग binary में उसको LSB बोलते हैं. And this particular digit has maximum weight, so this is called MSB, most significant digit. Okay, once again. And again, I'm organizing all the digits in a column. You can see this column. Okay, this is a column I'm referring. Where initially I will take LSD, okay, which is C, then B, and then MSB, and I will multiply with the power of 1/6. Weight is 0, weight is 1, weight is 2, and all kids mathematics. If you see once again, to get the final in decimal. Somebody's mic is open. Please mute your mic. Please mute the mic.
Hello?
Somebody's mic is open. Please mute the mic. Okay, okay. So I was talking that this calculation part is a small kids mathematics, and all that particular calculation you can do, and our final result is a conversion to decimal 2748. Now, using this particular algorithm, you will try to convert decimal to hexadecimal and hexadecimal to decimal, another 5 numericals, 5 plus 5. Okay, so again I will suggest that you take a pic of this particular PPT and take it as homework number 3. Already 2 homeworks I have shared, and this is the third homework. So if you see carefully, total 3 homeworks, and every homework have 10 different numericals, 5 plus 5. So total 13 numericals I have given for solving. Okay, in this particular week. So take a pic, and I will wait for a few seconds. Okay, I assume everybody has taken a pic, and again I'm going to the chat box. If you have any query, you are free to ask. Our major conversions are complete. We have discussed all major conversions. Now we will be doing some minor conversions. Okay, check it out. Any query, any question, any doubt, get it sorted. Can I go ahead? Very good. Excellent. Will you do this all homework? I will ask next Saturday. Okay. Okay, fantastic. Anyway, now let's.
Sir,
Yeah, tell me.
could you just show me the homework number 1 slide? My screen is not download.
Yeah, no problem. I'll go to homework number 1. Definitely. This is homework number 2. I think everybody must have taken up, but I will be here for a few seconds if anybody has missed it. Homework number 2. And this is homework number 1. This is homework number 1. Okay, I hope now everybody has all 3 homeworks. Okay, do it. You will enjoy and you will understand how number systems are so important. It is not just mechanical work, but it's a meaningful work. That is what we started this session at 5:30. Okay, I'm going ahead. Your concentration is required. We are in the second half of our today's session. Okay, and now we will think something more interesting. Okay, and this is very useful in your further studies of engineering. Okay, now the question is that if I'm in decimal and if I want to go to binary, octal, or hexadecimal, I will divide. If I'm in binary, octal, or hexadecimal, and if I want to come to decimal, I will multiply. Okay, In all these conversions, decimal number system was always there. Okay, let's check it out. See, यहाँ पे decimal है. मतलब I mean to say one of the number system is decimal. That is what I want to project. Okay, यहाँ पे decimal है. यहाँ पे decimal है. Let's go by numerical. Okay, हम लोग numerical सीखेंगे जो हम लोग ने डिस्कस किया. ठीक है, यहाँ पे decimal है. 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 यहाँ पे भी decimal है. Okay, so all these conversions we are thinking from human point of view because decimal is for human. And we are giving a thought ki how I can look into octal and how octal will look into my data, or hexadecimal will look into my data, or binary will look in my data. Okay. Now the next thought is that how you will convert octal number to hexadecimal number. How you will convert hexadecimal number to octal number. Observe it. I will remove these notations. Just give me 1 second or some time. Okay. Now, question is that how you will convert octal number to hexadecimal number. I'm talking about this particular conversion because now here there is no decimal involved. Okay. Let me make it more clear what we are trying to do. My question is how you will convert octal number into hexadecimal number. Okay. Or how you will convert hexadecimal number to octal number. Okay. Now one will say that, one will say that I will convert octal number to hexadecimal number or hexadecimal number to octal number through decimal. How? If I want to go this way, observe very carefully what I'm talking. This is the conversion I want to do. What I will do, I will convert octal number to decimal number because I know how to convert octal to decimal, and I will convert decimal number to hexadecimal number because I know how to convert decimal to hexadecimal. But this is a long method. It is possible. It is not wrong. You will get answer. But this method is a long method, and your teachers will not give any credits if you do this type of conversion because we need to understand a short method called direct conversion. I hope you are understanding what we are going to discuss. Okay, once again, let me bring it. I said whatever conversions we discussed 6 conversions total. In all those conversions, decimal number system was involved, and you get lots of numericals in your final examination. In routine examination, at least 5 to 10 marks of questions you normally get. Like how I have given you homework question, like that questions are asked in exam. That is one thought that we have done. Now the second thought is that if my number is octal, and if I want to convert in hexadecimal, then how I will convert. One way is that I will convert octal to decimal because I know. And I will convert decimal into hexadecimal. That also I know. But this is a long method. Okay, let me go other way also, so you will have a complete clarity what we are doing. Okay. If I want to convert hexadecimal to octal this way, then what will you do? Same way, I will convert hexadecimal to decimal and I will convert decimal to octal because I know both these methods, hexadecimal to decimal, decimal to octal. But again, this is a long way. Okay, we need some shortcut method. Let's try to understand how we do that conversion. Okay, so I'm going for it. Your concentration is required. This is all we have done. You can see. Okay, here we go. अभी थोड़ा ध्यान देना होगा. Okay, we are in the last phase of our discussion, around 1 hour 15 minutes. Okay, how to convert octal to hexadecimal? That is the question. Let's take one example. अभी यहाँ पे algorithm नहीं है. इसको समझो. यहाँ पे algorithm नहीं है. यहाँ पे कुछ logical thinking है. वो आपको समझना है. ठीक है? Let's take one example. I want to convert 555 octal number into hexadecimal number. Okay, so 555 octal is how much hexadecimal? That is the question. Then what I will do? I will write this particular octal number in binary. Okay. Okay. Now please listen very carefully what I am saying. उसके लिए आपको क्या करना होगा? उसके लिए आपको स्टैंडर्ड टेबल याद रखना होगा. वो टेबल बहुत ही सिंपल है. Okay, what is the table? Let's understand. That table is all octal digits. Octal digits are 0, 1, 2, 3, okay, 4, 5, okay, 6, and 7. Okay, it is going at the end of the string, but it is okay. It is fine. These are my octal digits. Okay, and what you have to do? You have to represent all these octal digits using 3 binary bits. 3, always 3. Why 3? Because which number system you are talking? Octal. आपका data कौन से number system में है? Octal में. Octal का मतलब है 8. Okay, and we can write 8 as 2 raised to power 3. Do you agree? 2 raised to power 3 is 8. And when I say 2, that means it is binary. Binary का मतलब है bits. Okay, so 3 bits you use to represent octal number. ये एक बहुत ही अच्छा question. And normally people don't answer this particular question. Question is how many bits do you use to represent octal number? Normally people say 3 bits, which is correct. Next question is that why you use 3 bits to represent octal number? And here is the simple mathematics. 8 is equal to 2 raised to power 3. Okay, and 2 is my binary number, the bits. So I need 3 bits to represent octal number. Okay, let's do it. 0 we write it as 0, 0, 0. Is it okay? 1 we write it as 0, 0, 1. Is it okay? Let me be slightly rough writing because I just want to use the time in a proper way. 2 is 0, 1, 0. Is it okay? 3 is 0, 1, 1. Is it okay? ये मुझे पता है आप प्रैक्टिस करना चालू करोगे तो आपको ये ऑटोमेटिक याद हो जाएगा. ओके, 4 is 1, 0, 0. 5 is 1, 0, 1. 6 is 1, 1, 0. 7 is 1, 1, 1. Okay, ये बहुत ही आसान है because essentially what we are doing, you are trying to convert each and every octal number into binary number. Okay, and if you remember, all octal numbers are same between decimal and octal. 0 to 7 is there in decimal also, and 0 to 7 is there in octal also. Okay, so this conversion you can easily do, or you can remember also. Let's take one example. If I want to convert 4 into binary, then 4 in octal and 4 in decimal is one and the same. So I will use that algorithm which already I taught you. I will take 4, I will divide by 2. Okay, and then quotient is 2 if you remember, and remainder is 0. Okay, again I will divide by 2. Quotient is 1 and remainder is 0. Further division is not possible, so quotient becomes 0, and this remainder I take as it is. That means 1, and I will pick up all the bits from bottom to top. 4 is 1, 0, 0. That is what I have written here, 1, 0, 0. Observe it. So this is the calculation for 4. So like that, all these calculations you can do if you are interested. But this table you can easily remember if you start solving numericals. Okay, so let me go back because this is one prerequisite for converting direct conversion. Okay, now I want to convert octal number into hexadecimal number, and my octal number is 555. Okay, what I will do? This octal number 555 I will represent in binary using this table. Okay, observe it. 5. What is the binary value for 5? Okay, always remember you should start with MSB. Am I correct? No, you should start with LSD, least significant digit. Okay, so let's start. What is the binary value for this particular 5? 101. Observe it. 101. So this is my 5. Okay, what is the binary value for this particular 5? Again 101. So this is my 5. Observe it. And what is the binary value for this particular 5? Again 101. So this particular 5. Okay, so what I have done using this table, I have represented 555 in binary directly. क्योंकि आपको ये टेबल याद करना होगा और जैसे आप प्रैक्टिस करोगे आपको याद हो जाएगा. ओके फाइन. नाउ इन सेकंड स्टेप बिकॉज़ मुझे करना क्या है, मुझे ऑक्टल नंबर को कन्वर्ट करना है हेक्साडेसिमल. ओके, तो पहले स्टेप में मैंने क्या किया, ऑक्टल को रिप्रेजेंट किया बाइनरी में. एंड इन सेकंड स्टेप व्हाट आई विल डू, I will rewrite this number. Observe it. 101. Okay, same number I have written here. If you observe carefully. Okay, 101101101. Okay, थोड़ा कलरफुल है, उसका रीजन बताता हूँ, उसका थॉट प्रोसेस क्या है. Now what you have to do, this particular binary, okay, this particular binary, you have to group in terms of 4 bits. Why 4 bits? क्योंकि आपको कन्वर्ट इसलिए करना है हेक्साडेसिमल में. Observe it. और हेक्साडेसिमल means 16. Okay, and I can write 16 as 2 raised to power 4. 2 raised to power 4 is 16. And again same mathematics. 2 means you are talking about binary, that means bits. And 4 bits are required to represent hexadecimal number. I repeat, 4 bits. Okay, this is bit basically because 2 means binary, 0 and 1 bit. So 4 bits are required to represent hexadecimal number. तो मैं क्या करूँगा, ये जो binary number है उसको 4 का grouping करूँगा. 4 का क्यों करूँगा, क्योंकि 4 bits मतलब hexadecimal number. Okay, I hope you are understanding what I am talking. See how. 1 2 3 4 ये मेरा पहला ग्रुप हो गया. ऑब्जर्व, मैं उसको मार्क कर रहा हूँ. आपको बहुत अच्छे से ध्यान से देखना है. दिस इज माय ग्रुप नंबर 1 1101. ये देखो 1101, इसलिए मैंने कलर में इसको हाईलाइट किया है. दिस इज माय ग्रुप 1. ओके, देन 0110 ये मेरा दूसरा ग्रुप है 4 का. ऑब्जर्व इट, ये मेरा दूसरा ग्रुप है 4 का. ओके, 0110 सी 0110. ओके, नाउ द प्रॉब्लम इज दैट मेरे पास सिर्फ एक ही बिट बचा है और मुझे ग्रुप करना है 4 का. Then what I will do, I will add 3 extra zeros. Can you see this? To complete the group of 4. This is called padding with 0. This particular activity where we add some zeros is called padding with 0. This is called zero padding. Word is PAD. Okay, this is called zero pad. Let me write it completely. Why we zero pad? We zero pad because I want to make group of 4 bits. और मेरे पास सिर्फ एक ही बिट है बचा हुआ. Okay, so I add 3 zeros to form a group 0001. Okay, and there is no problem because अगर आपका नंबर 9 है, decimal 9 एक example है, तो you can write 9 as 09. You can write 9 as 009. Value doesn't change. So you can add any number of zeros on MSB. आपका value change नहीं होगा. Okay, that's why we are doing padding with 0. Observe it. And then what you do, once you write binary number in terms of group of 4, directly you can write those numbers in terms of hexadecimal. Okay, because here I have written one table 0 to 7. Here if I continue 8, 9, okay, A, because don't forget in hexadecimal we have digits from A to F, which represents 10, 11, 12, 13, 14 and 15. So A, B, C, D, okay, E and F. Okay, so this is E and finally this is F. Okay, ये भी टेबल आपको याद रखना होगा और जैसे आप न्यूमेरिकल सॉल्व करोगे आपको याद हो जाएगा क्योंकि काफी सारी जगह पे हम लोगों को ऐसे ग्रुपिंग ऑफ 3 करना पड़ता है और ग्रुपिंग ऑफ 4 करना पड़ता है और डायरेक्ट वैल्यू लिखना है. दिस इज डायरेक्ट मेथड. ओके, सो let's write all these particular bits. 8 is 1000. Observe, यहाँ पे 4 बिट्स हो जाएंगे क्योंकि अगर आप 8 को डेसिमल में बाइनरी में कन्वर्ट करोगे तो आपको 4 बिट लगेंगे. 9 is 1001. 8 that means 10 is 1010. 1010 is my 10. B is 1011. C is 1100. This is 0 and this is also 0. D is 1101. E is 1110. ये याद करना है. And F is 1111. और ये ऑटोमेटिक हो जाएगा जैसे 2-3 बार में आपको होता है. ओके, तो आपको इसेंशियली आपको करना यह है कि आपको ये दो टेबल्स याद रखने हैं. इफ यू वांट टू डू डायरेक्ट कन्वर्जन ऑक्टल टू हेक्साडेसिमल और हेक्साडेसिमल टू ऑक्टल, बिकॉज़ these cases we are currently thinking or we are currently talking. Okay, let's go back and let's apply. So our discussion will be complete and now I will answer all your queries. Okay, once this discussion is done. Now if I see what is 1101, you will find that 1101 is D. Can you see this? That's why I written here D. So these 4 digits represents D. Then if I see what is 0110, then 0110, this 0 is just like a pad because I already said 0 on MSB is no meaning. So it is as good as 110 and 110 is 6. Observe it. You write it as 110 or you write it as 0110, it is one and the same. That's why this 0110 I'm writing it as 6. Observe it. Same way, this is 1. Okay, so you write this one as 0001 or you write it as 0001, it is one and the same because this is 0 pad. Okay, so this 0001 I'm writing it as 1. Observe it. And finally 555 octal becomes 16D in hexadecimal. And this method is a direct method. देखो आपको क्या करना होगा, आपको octal को कन्वर्ट करना होगा डेसिमल में और डेसिमल को कन्वर्ट करना होगा हेक्साडेसिमल. But that method is not counted and what method is recommended is this particular method. क्योंकि आपको ये टेबल भी याद हो जाता है. This is table number 1 and this is table number 2. इसका काफी एप्लीकेशन है आगे. जैसे हम लेक्चर प्रोग्रेस करेंगे आपको समझ में आएगा ये टेबल बहुत जगह पे यूज होता है. Okay, now if you have any query then I am ready to answer. Let me go to the chat box because I am talking almost from last 20 minutes, so I am in chat box. Okay, one query is coming from Piyush. Query is do we always add zeros in zeros only? Yes Piyush, 100%. You have to add only zeros when you are padding. Okay, you don't have to add any other value. क्योंकि थोड़ा अगर सोचा तो आपको समझेगा कि अगर मैंने दूसरा बिट ऐड किया जैसे कि 1, then your value will change. Okay, जैसे कि मेरा वैल्यू है 1 यहाँ पे देखो. See, this particular bit is 1. Okay, I want to make a group of 4. तो इसमें अगर मैंने 1 का padding किया तो it will become 111. मेरा value change हो जाएगा. So we always do zero padding on MSB. That is the answer. Yeah, any other query? I'm in chat box. A65 is asking why do we consider it as 10 in hexadecimal? Okay, I got your query. Your query is capital A is 65 in ASCII. Then why we consider it as 10 in hexadecimal? Gaurav, I think you are slightly getting confused. Let me remove your confusion. This particular A, what you are referring as 65 is an alphabet A. Please understand. And this particular A, what we are referring in hexadecimal is a digit A, which represents value 10. Understand? I think when I was talking about hexadecimal, I said a couple of times this A is not alphabet. This A is value. That is the difference between A ASCII and A hexadecimal. But it's a good question. Can we convert float values from decimal to binary? Yes, Joel. The algorithm for converting float value is different. Okay, and as per my understanding, in your syllabus, we are going to focus on integer conversion. But if I want to answer your question, 100% you can convert float values from decimal to binary, but that algorithm is different. Okay, it is not a division algorithm. Any other question? Check it out. Okay. If you do not have any question, then please write our magic words in the chat box so that we can go ahead. Yes, excellent. I'm happy. That's great. Okay. Now let's go ahead. Now we are reaching our saturation. Okay, because I know we are humans and we get tired. We put so much of hard work. So what will we do? I will discuss one more conversion with you. So all major conversions will be complete from your exam point of view. Okay. And then we will start with a very light discussion for rest of the time, which is a base for our coming session, because this is my normal methodology for teaching learning. That initial 2 hours 15 minutes we do some major discussion, and remaining 30-45 minutes we do some minor, and that is the start for our next session. That way we go on leaking. So I will go with one more conversion which is on the same track so that you get a complete clarity about what is the methodology, and that conversion is opposite. Observe it. Okay, I'm going ahead. Now what we will do, we will try to convert hexadecimal number to octal number. Okay, here what we did, we converted octal number to hexadecimal number. Now we will try to convert hexadecimal number to octal number. Okay, concentrate. And I'll be using this table because already this table is used as a reference. This conversion also we do directly. We don't convert hexadecimal to decimal and decimal to octal. Okay, teachers will not give you any credits. You have to do directly. Let's take example. I want to convert ABC hexadecimal to octal. Okay, so ABC hexadecimal is what value in octal? That's why there's a question mark. In step 1, we take our hexadecimal number. What is hexadecimal number? A, B, C. Okay, H is for hexadecimal. And I will convert it into binary. See, what is the significance of binary? Binary number system allows you direct conversion. Hexadecimal to octal, octal to hexadecimal. Okay, let's see how. What I will do, I will take every hexadecimal digit. Okay, let us take C. And I will represent it using 4 bits. If you are alert, you will agree that here every octal digit we have represented using 3 bits. Okay, मैंने आपको underline करके बताया. See, 101, 101, 101. Why? Because every octal digit or octal is 2 raised to 3. So 3 bits we use to represent octal number. Okay, now we are talking hexadecimal. I need 4 bits to represent hexadecimal number as per this equation. So what I will do, I will represent every hexadecimal digit using 4 bits. Observe it. C, what is C? 1100. Okay, C, 1100. You can observe. Next is B. What is B? B is 1011. Observe. 1011. What is next digit? A. Okay, we took B, now we are taking A. What is A? A is 1010. Observe it. 1010. Is it okay? पहले हम लोगों ने क्या किया था? पहले के कन्वर्जन में ऑक्टल नंबर था मेरा यहाँ पे. Okay? And for that I represent every digit using 3 bits. ये मेरा हेक्साडेसिमल नंबर है, तो मैं 4 बिट्स यूज करूंगा, ठीक है? Now let's go to the second step. Second step में हम लोग क्या करेंगे? हम लोग पूरा बाइनरी नंबर वापस लिखेंगे. See, 101010111100. ये पूरा नंबर मैंने वापस लिखा. And to convert into octal, I will group 3 bits. Why 3 bits? Because octal is 2 raised to power 3. Okay, so I need 3 bits to represent any octal number. So I will do grouping of 3 bits. Observe it. ये मेरा पहला grouping है. Okay, अच्छे से देखो. What is this number 100? Let's see. 100 is 4. So this particular value is 4. Let's do second grouping. This is my second group. Observe it. Okay, what is the value? That particular value is 7. 111 is 7. Okay, so let's write here 7. Okay, let's go third group. This is my third group. Observe it. Okay, what is the value? 010. 010 is what? 2. You can see 010 is 2. So we will write here value 2. Okay, and what is the last group? Last group is 101. Observe it. What is 101? 101 is 5. Observe it. So we write here 5. And now my hexadecimal number is directly converted to octal. 5274 is the value in octal. And we have done direct conversion. Okay. So if you understand one conversion, octal to hexadecimal, you will definitely understand opposite conversion, hexadecimal to octal. Only grouping and number of bits that you have to remember. Nothing else. And of course this table. If you have any queries, you are free to ask. Again, I'm in chat box. Yes, excellent, Joel. 5274 in octal. Very nice. I'm happy that you understood. Yeah. Any questions? Any queries? Any doubts that you want to ask? We have done total 8 conversions are complete. 6 plus 2, 8 conversions are complete. आपका exam का major conversion का part हो गया. Yeah. Any question?
Hello, sir.
Yeah, I'm listening to you. Tell me. Yeah, tell me. I'm listening to you. Yeah, tell me.
Hello, sir.
Yeah, I'm listening to you. I can hear you. Tell me.
Okay, sir, I will convert 16D into octal. So
Convert. Wait. Convert.
16D into octal.
1 minute. 1 6 D for Bombay or D for Don? Delhi. Okay. D for Delhi. That's great. 1 6 D. You want to convert into octal. Octal. Okay. It's simple. This is a hexadecimal number. Am I correct?
Yes, sir.
And you want to convert into octal. ठीक है. I'll just come out of chat box. Okay. Now. सेम मेथड यूज करना. लेट्स सी हाउ. मैंने अभी आपको जो पढ़ाया यहाँ पे एक्चुअली मैंने ये आगे के स्लाइड में लिखना चाहिए था क्योंकि वहाँ पे हम लोग ने हेक्साडेसिमल टू ऑक्टल. एनीवे सेम मेथड विल अप्लाई. लेट्स डू इट हियर. व्हाट आई विल डू, आई विल रिप्रेजेंट दिस हेक्साडेसिमल नंबर इन बाइनरी यूजिंग ग्रुप्स ऑफ 4 बिट्स. तो 1 मैं रिप्रेजेंट करूंगा 0 0 0 1. ओके, 4 बिट्स रिप्रेजेंट करूंगा. 6 आई विल रिप्रेजेंट एज 110. ओके, लेकिन मैंने आपको पहले ही बताया कि 110 इज अ 3 बिट. मुझे 4 बिट रिप्रेजेंट करना है तो मैं 0 का ऐड करूंगा. सी, तो आई विल रिप्रेजेंट 6 एज 0. ये मेरा ऐड हो गया 1 1 0. ओके, दीस आर माय 4 बिट्स. एंड डी आई विल रिप्रेजेंट एज 1101. ओके, 1 1 0 1. ठीक है, ये हो गया मेरा 4 का ग्रुप. And now I will start grouping with 3 क्योंकि मुझे कन्वर्ट करना है हेक्साडेसिमल से ऑक्टल में. ओके, तो ये मेरा हो गया पहला ग्रुप. ऑब्जर्व इट. 101. So this value is 5. ये हो गया मेरा दूसरा ग्रुप. ऑब्जर्व इट. What is this particular value? This particular value is again 5 because this is also 101. Okay, this is my next group. This is also 5 101. Okay, and this particular value is 0 because 0 0 0 is 0. Let me complete the group. Okay, ये मेरा है लास्ट वाला ग्रुप. So your value is 0. Forget this 0 because this is on MSD side. MSD side 0 5 5 5. तो ये वैल्यू है. ये देखो, इसे मैंने यहाँ पे कैलकुलेट किया. मुझे समझा आप रिवर्स पूछेगा तो 16D becomes 555 and that is the conversion of hexadecimal to octal. That is the answer to your query. I hope I have cleared your doubts. That's it. Okay, now let's go ahead. The concentration is required. थोड़ा डिस्कस करेंगे कन्वर्जन का और उसके बाद थोड़ा आगे का पार्ट हम लोग चालू करेंगे. मतलब नेक्स्ट सैटरडे हम लोग जो करने वाले हैं उसका थोड़ा पढ़ाई करेंगे. ओके, इसका डिटेक्शन मैंने आपको आज दिया नहीं है क्योंकि ज्यादा करके कैलकुलेशन पार्ट है, मैथमेटिक्स है, एल्गोरिथम पार्ट है और मैंने सब कुछ पीपीटी पे आपको पढ़ाया. ये पीपीटी में शेयर करूंगा आपके साथ में एंड आई होप व्हाटएवर इज इंपॉर्टेंट आपने उसका टिक लिया होगा और ऑल होमवर्क्स ऑलरेडी आई हैव गिवन. एनीवे लेट्स मूव ऑन. व्हाट आई विल डू, आई विल अगेन गो बैक टू आवर स्टार्ट डिस्कशन. ओके, ऑब्जर्व इट. दिस is a journey of our today's session. It's a nice journey, nice session. यहाँ पे and I will place all these particular arrows. Okay. आपने अगर बहुत केयरफुली ध्यान से देखा होगा तो मैंने इसके साथ बाकी भी दो कन्वर्जन आपको सिखाए. Okay. Let me show you how. I taught you how to convert octal to hexadecimal directly. Okay. And I taught you how to convert hexadecimal to octal directly. Okay. ये हम लोग ने अभी डिस्कस किया. ठीक है. How you will convert binary number to octal and how you will convert octal to binary ये पॉसिबिलिटी है, बरोबर? लेकिन वो मैंने आपको सिखा दिया ये डिस्कशन में. How? Simple. If you want to convert octal to binary, मैंने आपको बताया every octal digit you represent by 3 bits. जो हम लोग ने यहाँ पे किया. Okay. And if you want to convert binary to octal, तो आप binary के 3 के ग्रुप बनाओ and represent it using octal number, वो भी हम लोग ने यहाँ पे किया. So during this particular conversion, we have also studied how to convert octal number to binary number and binary number to octal number. If you want to convert octal to binary, represent every digit using 3 bits. जो टेबल मैंने आपको पढ़ाया 0 to 7 का. And if you want to convert binary to octal, then make group of 3 bits. Okay, from LSB to MSB. जो मैंने आपको पढ़ाया conversion, ये conversion. Same way, if you want to convert binary to hexadecimal or if you want to convert hexadecimal to binary, वो भी हम लोग ने पढ़ा ये conversion में. Indirectly. So we use our time in a more practical way. क्यों? मैंने आपको पढ़ाया. If you want to convert binary to hexadecimal, okay, then make a group of 4 and that 4 bits you represent by hexadecimal digit. जो दूसरा टेबल मैंने आपको बताया. That all we have used. And if you want to convert hexadecimal to binary, I said every hexadecimal digit you represent with 4 bits. और अगर वो 4 bit नहीं हो रहा है तो 0 ऐड करो. So in all effect is that हम लोग ने all conversion possibilities we have covered. Observe it. Okay. We have done all 12 conversions in 2 hours and 20 minutes. And you have to just review it, just study it once or twice, and this concept will be concrete. You will get full marks for any question based on this conversion. Okay. So what I suggest you is this particular session is being recorded. Already homework is given to you. Listen this particular session once again, as per your convenience, as per your time, and then try to solve all those particular homework questions on your own without referring anything. Okay. And our discussion will be complete, and your understanding will be complete. Okay. Now let's go and start discussion of some small concept, and we will carry on with those details in the next Saturday. Okay. But that discussion will start today because I want it next Saturday. That is the reason. Okay. I just want to ask you one question. कि मैंने यहाँ पे जो मार्किंग वगैरह किया है, when I was teaching you, वो मैं पीपीटी में वैसे ही रखूँ. When you share with you, PDF फॉर्मेट में शेयर करूँगा, तो ये मार्किंग वैसे ही रखूँ कि मार्किंग निकाल दूँ. What is your requirement? ये सब मार्किंग्स, all this.
रहने दो सर.
ऐसे रहने दूँ कि निकाल रहने दूँ ये सब मार्किंग्स. हाँ सर. ठीक है. तो मतलब अकॉर्डिंगली आई विल जनरेट PDF. इसलिए मैंने आपको पूछा कि वो मार्किंग्स कभी बहुत यूजफुल है, जो हम लोग पढ़ते हैं तो उसका रेफरेंस मिलता है इसलिए. ठीक है. तो वो मार्किंग्स मैं निकालूंगा नहीं, मैं वो मार्किंग्स रखूंगा. ये टेबल भी रखूंगा. ओके. ये सब रखूंगा. See all this. Okay. ये टेबल भी रखूंगा. Okay. For your reference. ठीक है. Anyway. Let's go ahead. Let me see anything in chat box, any query or okay. That's great. People are saying this marking. Yes. Definitely. Now focus. I know. Now you are tired and but you have to move on. कि हमारा सिलेबस बहुत ज़्यादा है तो लोग डिस्कस तो करेंगे लेकिन थोड़ा लाइट करेंगे. Let's go ahead. This is the last slide I was discussing. Okay, let me go there. So this is the last slide I was discussing. And just for your clear understanding, कहीं पे कुछ confusion हो इसके लिए. See, this is conversion of binary to octal. ये देखो मैंने 3 का ग्रुप बनाया और उसको रिप्रेजेंट किया octal digit से. मैंने 3 का ग्रुप बनाया और उसको रिप्रेजेंट किया octal digit से. मैंने 3 का ग्रुप बनाया और उसको रिप्रेजेंट किया octal digit से. This is called binary to octal. ये मैंने आपको मैप करके बताया कि this we have covered indirectly मतलब ये प्रोसेस में. Okay, same way यहाँ पे अगर आप देखोगे तो ये मैंने 4 का ग्रुप बनाया. Okay, and this is represented by D. ये green 4 का ग्रुप बनाया and represented as a 6. ये black 4 का ग्रुप बनाया and represented as 1. This is binary to hexadecimal. Okay, that is why I was mapping. I thought practically I will show you so that it is more clear. Anyway, let's move. Now, after we know what is a number system, what is the significance of number system, what are different types of number system commonly used, and what are 12 different conversions meant to that are possible on number system, of course with lots of homework for practice. Now let's go one step ahead and let's raise a question. If I'm working on a machine like a computer, laptop, desktop, mobile phone, because mobile phone is also a computer nowadays, then I always work using binary number system. Okay, because in the beginning only I said the language of computer is zeros and ones, called as binary, called as bits. So the question is how we are going to work on this particular bits. अभी ये मुझे पता चला कि मेरा information अगर decimal में है तो वो bits में कैसे आएगा? Numbers. We did it for numbers. Okay. Now the next question is that एक बार वो bits में आ गया, मेरा information पूरा bits में आ गया, then how I'm going to work on it? ये आगे का question है. Okay. Now we will see how it is meaningful and how it is going. Okay. I repeat. My information like decimal, if it goes into binary, it is converted into binary. I'm aware how to do that conversion. Next question is how I'm going to work on that particular binary or bits. For that, we need digital logic circuits. Okay. Let me explain. You may have studied half-wave rectifier, full-wave rectifier in subjects like BEE or basic electronics. Okay. Now in that particular circuits, half-wave rectifier, full-wave rectifier, you use diode, you use transformer, you use filter. Okay. Those all circuits are called electronic circuit. Please understand. Okay. Electronic circuit. We use some components like we use diode. I hope you must have seen diode or all components you have seen in your labs of the institute. Similarly, when we want to work on bits 0 and 1, क्योंकि अगर आपने डायोड या ऐसा पढ़ा होगा, so normally they are called as analog circuit, ANALOG, क्योंकि आपका जो इनपुट रहता है वो साइन वेव रहता है, अगर आपने रेक्टिफायर्स पढ़ा है तो. Question is that if I want to work on bits, then what I'm going to use? Am I going to use diode? Am I going to use resistor? Am I going to use capacitor? Am I going to use inductor? Answer is no. वो सब सर्किट कुछ काम के नहीं है. Diode, resistor, capacitor, inductor, that all is useful for analog circuit. They are not useful for bits, zeros and ones. For that, we need some different circuits which are called digital logic circuit. Okay, so let's define what is a digital logic circuit. Don't write. Digital logic circuit are the circuits used to process bits, zeros and ones. आपके कंप्यूटर में जो सर्किट रहता है, they are all digital logic circuit because they process bits, zeros and ones. And there are two types of digital logic circuit. One is called combinational circuit and second one is called sequential circuit. Okay, what are the types of logic circuit? There are two types. One is combinational circuit and second one is called sequential circuit. Let's see what is a combinational circuit and what is sequential circuit. See the definition. If you read the definition, you will find combinational circuit is a circuit in which output depends on present state of input. Okay, आपको अभी कुछ भी सोचना नहीं है, आपको सिर्फ डेफिनेशन के ऊपर फोकस करना है। ये मैं आपको पढ़ा रहा हूँ, आगे आ सब कुछ। ओके, आपको ज्यादा समझ में नहीं आएगा, आपको पढ़ना है डेफिनेशन। आई रिपीट, आउटपुट डिपेंड्स ऑन प्रेजेंट स्टेट ऑफ इनपुट, सच सर्किट्स आर कॉल्ड कॉम्बिनेशनल सर्किट्स। ठीक है, क्वेश्चन इज व्हाट इज सीक्वेंशियल सर्किट? लेट्स सी व्हाट इज द डेफिनेशन ऑफ सीक्वेंशियल सर्किट। आउटपुट डिपेंड्स ऑन प्रेजेंट स्टेट एज वेल एज पास्ट इनपुट, सच सर्किट्स आर कॉल्ड सीक्वेंशियल सर्किट। ओके, आपका जो कंप्यूटर है उसमें ये सर्किट्स रहते हैं, कॉम्बिनेशनल सर्किट्स एंड सीक्वेंशियल सर्किट्स। एनी डिजिटल डिवाइस that we see, in that we use combinational circuit and sequential circuit. Okay, definitions are Inft. Okay, now let's start. Understand. Okay, हम लोग ने define किया what is a digital logic circuit. A circuit used to process bits, zeros and ones is called digital logic circuit. We classify digital logic circuit in two types: combinational circuit and sequential circuit. ठीक है? Now let's understand it through an example. आपका focus होना जरूरी है. Okay, यहाँ पे we are going to discuss. ठीक है? One type of combinational circuit is called logic gate. Observe it. LOGIC. Okay, I'm writing it in rough because I want to write, but I want to write quickly. Okay, logic gates. GATES. Okay, this we will be discussing starting today, and we will be discussing in detail in coming session. Okay, so I'm writing very clearly what is the name. It is logic gate. Logic gate is a type of combinational circuit. Okay, वो क्या है? Let me explain. Okay, example से आपको मैं explain करता हूँ, आपको ज़्यादा समझ में आएगा. ठीक है? Suppose I want to develop one application. Okay, and that application is I want to control one light. Okay, light मतलब LED या फिर any type of visible light. Okay, like a light bulb. I want to control one light bulb or LED. And my requirement is, this is my switch 1, okay, let us call it as S1. This is my switch 2, let us call it as S2. Okay, and my requirement is that when one of this particular switch is closed or applied, my light should glow. Okay, and when both the switches are applied, my light should not glow. Are you understanding what I'm talking? Okay, ये जो मैं बात कर रहा हूँ उसको बोलते हैं लॉजिक. I repeat once again. I want to develop an application. अब वो application क्या है कि मुझे LED कंट्रोल करना है, LED लाइट एनीथिंग आपने देखा होगा. And how I want to control कि I have two switches. If one of the switch is on, then that LED should glow. दोनों switch अगर open है या दोनों switch अगर closed है, that LED should not glow. This is my requirement. Okay, this type of thought is called as logic. ये आप analog circuit से नहीं कर सकते. Analog circuit मतलब diode, inductor, capacitor, उससे नहीं होगा. Because what thought we apply is called as logic. उसके लिए अलग circuit लगते हैं. That is called logic gates. Understand? ये application में we need some circuits which are called logic gates. Okay, I'll give you one more example. Suppose I want to develop one application because when I started this particular session, I said that currently I'm doing PhD and that I'm doing it from GTI in the domain of IoT. I want to build this world. That is the reason I started with my background. IoT, Internet of Things. Okay, this is one important domain where huge employment is going to come. IoT, machine learning and data analytics. Okay, एक IoT एप्लीकेशन हम लोगों को बनाना है और उसमें हम लोगों को करना ये है कि एक बजर है यहाँ पे, बजर मतलब साउंड आता है उसको बजर बोलते हैं. ओके, और ये बजर मुझे यूज करना है और वो बजर मुझे ऐसे यूज करना है कि अगर कुछ फायर डिटेक्ट हुआ, ओके, या फिर अगर कोई मेन डोर जो है वो अगर किसी ने यूज किया अदर देन ऑथराइज्ड पर्सन, देन दिस बजर शुड फायर और दिस बजर शुड साउंड. ओके, नाउ इसके लिए रिक्वायरमेंट क्या है कि इसमें से कोई भी एक्टिविटी अगर होता है दिस बजर शुड साउंड. मतलब फायर डिटेक्ट हो गया और OR, अंडरस्टैंड, unauthorized person comes from the door, then this particular buzzer should sound. This all we do using logic gates. तो इसका permutation combinations vary होगा depending on the application. हमेशा सेम नहीं रहेगा. हो सकता है मैं ऐसे भी बोलूं कि मेरा buzzer should be active when both conditions are satisfied. दोनों होना चाहिए. ऐसे भी हो सकता है. This all we handle using logic gates. Okay. There are many types of logic gates. Okay. And one type of logic gate is called OR gate. Observe it carefully. Okay. This I am teaching and I will be continuing further. उसको क्या बोलते हैं? OR gate. ऐसे लिखा है देखो. This is called as OR gate. ये सिंबल है. आपको डायोड का सिंबल पता है, हम लोग डायोड कैसे दिखाते हैं, हम लोग डायोड ट्रायंगल से दिखाते हैं. दिस इज द सिंबल फॉर डायोड, इफ यू रिमेंबर. ओके, यू हैव अ सिंबल फॉर रेजिस्टर, यू हैव अ सिंबल फॉर कैपेसिटर. वैसे देयर आर सिंबल्स फॉर लॉजिक सर्किट्स, लॉजिक गेट. ओके, दिस गेट इज कॉल्ड एज OR गेट. अभी क्वेश्चन आएगा कि हम लोग इसको ऊपर काम कैसे करते हैं, मतलब क्या है. लेट्स ट्राई टू अंडरस्टैंड. ओके, व्हाट आई विल डू, ये थोड़ा यहाँ पे जगह बनाता हूं, जस्ट गिव मी फ्यू सेकंड्स. ठीक है, लेट्स कंटिन्यू. नाउ दिस गेट इज कॉल्ड एज OR गेट. दिस गेट हैज टू इनपुट्स. सी, यहाँ पे डेफिनेशन में मैंने इसको लिख दिया है इनपुट. ओके, दिस गेट हैज टू इनपुट. वन इनपुट इज कॉल्ड एज A एंड सेकंड इनपुट इज कॉल्ड एज B. ओके, एंड दिस गेट हैज वन आउटपुट व्हिच इज नॉर्मली रिप्रेजेंटेड बाय Y. ओके, दिस इज नॉट अ रूल, लेकिन हम लोग Y नॉर्मली रिप्रेजेंट करते हैं लॉजिक गेट्स में. Okay, and this particular logic gate we represent using a table like this. A, okay, this is my input number 1. B, this is my input number 2, and Y is my output. Okay, what is the table? Observe it. If both the inputs are 0, you can see I'm talking in terms of bits 0 and 1. Then my output is also 0. If one input A is 1, bit 1, and other input B is bit 0, then my output is 1. If input A is bit 0, input B is bit 1, then my output is 1. If input A is bit 1, if input B is also bit 1, then also my output is 1. We get such table. Okay. ठीक है, and what we observe is that when one of the input is 1, you can see one of the input is 1, my output is 1, and when both the inputs are 0, my output is 0. This table is called truth table. TRUTHTABLE, truth table. That is a label, or I can say description of this particular table. Okay, now pay attention for last 10 minutes. We are going to conclude. Okay, and we are going to continue logic gates in the coming session. Okay, observe very carefully. Can you see this particular Y depends on present input and there is no past input. Okay, whatever input I apply, accordingly my output will be generated. Whatever inputs you apply at time t, accordingly my output will be generated. That means my output depends on only present input. Such circuit is called combinational circuit. Observe it carefully. Output depends on present input. There is no memory. This circuit में memory नहीं है. Because what is the meaning of past input? Past input मतलब previous, मतलब history, मतलब memory. So sequential circuits have memory and combinational circuit do not have memory. This is a big difference. Okay, आपका जो RAM, ROM ये सब जो memories है, they are all sequential circuit. Because that's the memory. But यहाँ पे past input नहीं है. Such circuits are called as combinational circuit. Okay, what we are currently discussing, logic gates. Okay, there are many types of gates. हम लोग उसको अच्छे से PPT में लेके आऊंगा. ये मैंने अभी आपको हाथ से PPT पढ़ाया just because I want to start. But when we continue next Saturday, then I'm going to use all my PPTs and standard symbols directly. I'll be using, and on that I will be discussing. Okay, because I want to use the time in a efficient way. That's why. There are many gates basically. You have OR gate, AND gate, NOT gate, XOR gate, NAND gate. Okay, these are some common types of gates. We'll be discussing. Don't worry. Last, but important, and then we'll conclude. Question is how we represent this truth table. Okay, using equation, symbolic. Okay, that we do like this: y is equal to a. Is it okay? और b. आपको लगेगा सर मेरे प्लस लिखा है करके, लेकिन ये जो सिंबल है, ये सिंबल और गेट का है. ये सब मैं आपको बताऊंगा इन कमिंग सेशन. ओके, आई जस्ट वांट टू कंप्लीट दिस वन गेट. इसलिए मैंने आपको ये बताया. सिंबल हम लोग ने डिस्कस किया, ट्रुथ टेबल डिस्कस किया, कॉम्बिनेशनल सर्किट के साथ मैप किया. दैट्स व्हाई आई थॉट आई शुड राइट सच टाइप ऑफ एक्सप्रेशन. ओके, दिस इज कॉल्ड एज बूलियन एक्सप्रेशन, BOOLEAN. ओके, अभी वो सब हम लोग अभी पढ़ेंगे नहीं. ठीक है, अभी हम लोग यहाँ पे कंक्लूड करेंगे. ठीक है, फाइनली बिफोर आई कंक्लूड आई जस्ट वांट टू गो बैक, क्योंकि एक पॉइंट है जो मुझे आपके साथ डिस्कस करना है यहाँ पे. आई थिंक यहाँ पे करूंगा तो अच्छा रहेगा, क्योंकि वो डायग्राम में बहुत दूर जाना पड़ेगा. ठीक है, लास्ट पॉइंट आई जस्ट वांट टू डिस्कस विद यू इज दैट again I'm coming in conversions of the number system because today that is a major discussion we have done. Okay, and I want to complete in all respect without leaving anything pending. That's why. One important point that you should understand is when you are trying to convert octal number to hexadecimal number or hexadecimal number to octal number, whatever case may be, normally people make a big mistake like this. See, ये अगर मेरा binary है suppose, okay, एक random binary में लिख रहा हूँ, ये अगर मेरा binary है, तो what mistake people do, अगर ये मुझे convert करना है octal में, let's assume octal में convert करना है, ठीक है, तो what mistake people do, they will start grouping from MSB to LSB, ऐसे grouping करते हैं. Observe, ऐसे grouping करेंगे, ये पहले group करेंगे और उसके बाद ये group करेंगे. Okay, this is wrong. Please understand. अगर आपने केयरफुली देखा होगा, मैंने आपको क्या सिखाया, मैंने हमेशा ये ग्रुपिंग किया है LSB टू MSB. ऑब्जर्व इट, ये मेरा बाइनरी है 1 0 1 0 1 1. ओके, ये मेरा बाइनरी है, तो मैंने ग्रुपिंग कैसे किया है, मैंने ग्रुपिंग ऐसे किया है. ऑब्जर्व, दिस इज अ ग्रुप एंड दिस इज सेकंड ग्रुप एंड दिस इज करेक्ट. नाउ यू विल से दैट दोनों सेम है, उसमें कोई डिफरेंस नहीं है. डिफरेंस इसलिए नहीं है क्योंकि आपका ग्रुपिंग परफेक्ट ग्रुपिंग हो रहा है, उसमें जीरो टाइम नहीं है. इसको समझो. ओके, इफ आई टेक वन मोर एग्जांपल, सी 1 1 0 1 1, ऐसा अगर मैंने एग्जांपल लिया. ओके, एंड इफ यू स्टार्ट डूइंग ग्रुपिंग फ्रॉम MSB, इसको ग्रुप किया. ओके, अभी यहाँ पे प्रॉब्लम क्या है, ग्रुपिंग के लिए दो ही बिट्स है, तो व्हाट पीपल विल डू, दे विल ऐड 0 हियर. यहाँ पे 0 करेंगे. मैंने आपको हमेशा बोला है 0 करेंगे MSB पे करना है. ओके, मोस्ट सिग्निफिकेंट बिटवीन पीपल आर डूइंग इन LSB एंड दे कंप्लीट दिस पर्टिकुलर ग्रुपिंग. ओके, दिस इज रॉन्ग. व्हाट यू नीड टू डू, ऑब्जर्व इट, ये मेरा नंबर है 1 1 0. ओके, 1 1, ये मेरा नंबर है. नाउ यू हैव टू ग्रुप दिस वे, ऑब्जर्व इट. Okay, and now you have to add 0 here because your grouping has to be group of 3 octal 3, and this will be your second group. Okay, you can see values are different. Okay, and this is correct. That's why always remember, whenever you are doing direct conversion like binary to octal, grouping of 3, binary to hexadecimal, grouping of 4, okay, or octal to hexadecimal, hexadecimal to octal, you have to do grouping from LSB to MSB always. And if required, you have to add 0 or 0 padding on MSB, not on LSB. Okay, I hope this particular point also you have understood, and now there is no confusion. If you have any queries, you are free to ask. Check it out. I'm in chat box. Check it out. We will summarize and we will end our session. Okay, it's a good discussion, and I enjoy teaching you guys. Check it out. Anybody, any question, any doubt? Okay, that's great, Simran. Thank you. Thank you, Joel. What others are doing? I'm really surprised. Okay, friend. Thank you. Parvati, Yashas, Nitesh, Piyush, great. So nice. Thank you. Okay. Okay, let's summarize last 2 minutes and end of the session. So today we discussed about number system, common number systems, all 12 conversions between different number systems. Very important for your exam. ये 12 में से कम 5 या 10 मार्क के लिए conversion आएंगे, any combination. And we just introduced what is a digital logic circuit, what is combinational circuit, sequential circuit, and just started with logic gates, which will be continuing on coming Saturday. Of course, we will start